All right, well, thank you everybody for coming today. I'm Jon Ferraiolo, and I'm going to be talking about mobile first, cloud first graphics. And we have a code name for the project we're working on at IBM called Verona. So there's a little bit of background about myself. I was very much involved with the early days of SVG. I was the sole editor of the SVG 1.0 spec. So I submitted one of the original proposals before the W3C started SVG, the SVG effort. Then I was, there from the beginning and wrote most of the words in the original SVG spec. And then I stepped, that SVG became a standard in 2001, and I went off and did other open web things for the most of it. And now recently, IBM is, that's when I was at Adobe. Now I'm at IBM, and IBM has put me back on graphics. So this is sort of a return to SVG and graphics here. So, and the thing is with the cloud, with the cloud is the big thing, and of course mobile. So this talk is about this project, Verona. And what we describe it in at IBM is visualization as a cloud service. We focus on mobile because that's the up and coming platform, and the current status is that we're still early in the development. The content of this talk and the target audience, what I'm going to talk about is mostly about how we've architected it and our implementation strategy. So it's going to be a geeky talk to some level, not many cool demos, or not any cool demos maybe. So the big thing here is like the approach that we're taking, which we think is leading edge in some aspects, and that other people can look at what we're doing here, and it might be food for thought about how to do graphics in the future. I encourage questions from the audience. If you have anything at any time, ask it. If you have comments about ways to do something better, I'd like to hear that too. Verona executive summary. So we're focused mostly on business charts, or the sorts of things that IBM customers would want to look at. So things that are data, representing data visually. So what we have is a modern visualization stack. We're taking advantage of the cloud, and we're trying to make it so it has mobile interactivity. The delivery format is most of the stuff I've seen at this conference consists of client-side JavaScript that goes and executes purely on the client. And that's been the traditional way that things have been done. So what we're trying to do with Verona is leverage the cloud. And it's being delivered as a cloud service, and IBM is endorsing this thing called Cloud Foundry, which is an open alternative to Amazon. There's OpenStack is like the low level, and then Cloud Foundry is the programming as a service, the PaaS stack. And IBM and several other companies, there was just an announcement about SAP getting with Cloud Foundry. So that's where we're delivering Verona first. And then mobile first, and the key thing is mobile interactivity and making sure that performance is good on mobile. With this project, who we're targeting spans from professional developers to non-programmers. So we're trying to make an open architecture with many extensibility points where we do basic things automatically, but there's all sorts of extensibility points so that people who have specific needs can extend the project. And then for non-programmers, we have a visual authoring tool, which I'll demonstrate in a moment. And for lightweight developers, which is actually the sweet spot that we're targeting here, is that in the IBM world, and I think this corresponds to the whole world, the people at this conference tend to be really strong programmers. We're leading edge types. So we can figure out WebGL, we can figure out D3, all the newest things in JavaScript we can figure out. But we're sort of in the bell curve, over on the one edge of the bell curve, and the majority of the bell curve are people who can do some things with JavaScript, some things with CSS, but aren't experts. And so what we're trying to do with Verona is to expose graphics to those people who are in the more middle of the bell curve. Current status is some things are working today, and I'll demonstrate that. We got a lot of foundation stuff going, but we still have a lot of things to do. Where is Verona ultimately headed? Well, it's an emerging technologies product. IBM has this group that is allowed to do cool new things, and we try to sell it to the product groups, and sometimes we do and sometimes we don't. But it's a technology exploration. Ultimately, what will happen with this work? Well, I personally would like to see it approved to be contributed to open source. It isn't yet, and IBM has a process that we have to go through to get that approved. And then we'd also like to get it to be productized. And I'll go into that in a bit. So for now, the cloud-first nature. So with Verona, you typically use it by putting in a div tag, an empty div tag, and then a script tag which points to it. If you look at the far right in the blue colored text over there on that script tag, it says selector equals %23. That's URL encoded hash. So that's a CSS selector, an ID selector for that div. And that's all you do. You put that into your HTML, and then a chart appears. And what chart appears is described by the spec value, the thing in red. That's the visualization that you saved previously. And then the data is another URL parameter. So that's the thing that you typically do. And how it gets rendered is all automatically done by the chart type. And it also includes automatic interactivity. So I'm going to go switch over here to the browser here. And this is one of the examples, a line chart that we have that's with Verona. And so there's this little HTML file, and I'll go look at the source code here for the HTML file. And what we have here is that there's an ID element, a div, where it says my chart right here. And then you have to put that in, and then you put in the script tag into your HTML. And then the library takes care of it all. So there's some parts that run on the server and some parts that run on the client. So now for the lightweight programmer and the non-programmer, we've developed a visual design tool, a GUI for doing charts, for building charts. So this is the home page. So we're packaging up the Verona service as a cloud service. You can run it off the cloud with this tool. And so what I would do here, first thing I do is I log in. So every user is going to have his, so I'm going to go make a login here. Every user gets his own private area. And then I go to run the app, and I have no files created, and I'm going to go create a file. And the model is like Google Docs or the Google things, where automatically the file is saved on the server, and you make changes and it automatically updates. So here I can switch between line chart, bar chart, etc. And this tool, after you've set up all your options, the tool will give you show you the HTML snippet that you insert into your page. So we've got a chart designer. Each user gets his own private area. If I go back here to this thing here and I go to click on this button here, it takes me back to my home page, and it shows me that I've now created a new chart. And so if I create more charts, then they're listed on that page. So right now, when you get into the cloud and you have user system, you have to have a group system. Otherwise, it won't be useful. We haven't done that yet. Right now, your visuals are private to you, and we need to expose a grouping system and probably integrate with various enterprise grouping systems like LDAP and things like that. This is currently running internally on an IBM cloud. So I'm running localhost right now, but it's available right now to IBM people running on our local cloud behind the firewall. And this thing is part of a general IBM effort to enable people to do application development totally on the cloud. So there's this project, Orion, Eclipse Orion. It's somewhat of a competitor with Adobe Brackets that IBM is doing. And we have this an initiative that we've launched at the Jazz Foundation called Jazz Hub, where you can go and create your own development projects and totally do development in the cloud. So usually it's very good for Node development, and you can do JavaScript editing using a cloud-based editor. So the idea here is that this is the visualization component that would fit into a web development cloud-based tooling system. So now on the mobile side, we all know about some of the challenges with mobile development in general and mobile graphics in particular. So mobile devices have high latencies on their networks. So if you do a lot of network requests, things can slow down because it doesn't have as many simultaneous ports. The back-end services wait longer before they'll give you a response. So the thing is, if you go to a normal web page that hasn't been mobile optimized, it could take a really long time for it to display. The same thing is true with graphics. In graphics, you get hit by the limited memory, and then they have limited caching. So if you have a file that you've been using on a desktop browser, that file will likely be still in the cache, but on mobile, the caching is much less, and the file will have to get retrieved a lot more often. And the big thing is the slow CPU, and which generally translates into slow JavaScript execution. So if you do D3 on a mobile device, and you have a lot of data points, it'll often be slow in the rendering, and certainly if you have any animations. And one of the reasons is just parsing the JavaScript can be, if you have a lot of JavaScript, that can be slow. But then if you do any interactivity like pinching and swiping, and you have to do an animation, the animations in JavaScript can be very jerky. And if you use JavaScript for the animation, either using SVG or Canvas, and CSS3 is often better, but still with SVG, if you try to animate it, not all these things will be hardware accelerated, and you'll get jerky animations even with CSS3. So the solutions that we're pursuing with Verona is to push as much computation to the cloud as possible. So we're trying to have a joint client-server architecture. We want to try to minimize what gets down to the client. Instead of sending down big libraries of JavaScript, of which you only use like 5% of the code, we're only downloading the JavaScript that you need. And then we're utilizing clever client-side techniques to achieve smooth visual effects. So we have a client-server architecture for preparing and rendering visuals. So we have, the idea is that Verona will ship with a set of built-in visual types, and we'll also have a plugin facility so that the cloud service could add things from the community or custom things that you as a developer write yourself. Each visual type is a complete implementation of all things needed to render that visual. Right now, we're using D3 for all the examples I'm showing, but there's nothing about Verona that's tied to D3. We could use WebGL or Canvas if that was appropriate, and we anticipate that we will be doing that in the future, using both of those. So each visual type, think of a visual type as like a bar chart or a bubble chart, that each of them consists of two central files, a server.js file and a client.js file. And you don't have to put anything in either. You can put all your implementation in the server. You can put all your implementation in the client. It's up to you, the developer of a chart type, where you want to split the logic. So I'm going to go off here and show you that there's, this is the implementation, I think, of the bar chart. So there's the server file and there's the client file. So right now, the server file doesn't do all that much. In the current implementation, it loads the data and does data preparation on the server, so you don't have to do it on the client. And then on the client, there's a little bit of data prep. That's mostly because JSON doesn't support date formats natively, so you have to go and switch a string to a date. And then there's a thing to draw the axes, set the colors, and draw the bars. And then we do the animations in this wrap-up routine. So anyway, that right at the moment, because of using D3, D3 sort of focuses mostly on the client, although I'll get into server-side D3 in a second. But in the future, what we're looking at here is server-side data reduction. So if you know that your chart type is 300 by 300, I mean your chart ultimately is going to be 300 by 300 pixels, there's no need to throw 10,000 data points to the client. So the server can sample or whatever to reduce the amount of data that goes to the client. On the client-server thing, the client and the server could talk to each other, and then we can implement a level of detail thing so that you reduce the data, but as you zoom in, you can go ask the server to do more processing to re-render. And then the streaming data also is another thing that we're actually working on that right now. Part of this architecture is to minimize the amount of JavaScript that goes to the client. And to address that, we're leveraging this technology called require.js. Is anybody familiar with AMD, require.js, common.js, and all these things? The way there's these pseudo standards that are out on the in the community right now for how to define modules, reusable modules in JavaScript. And there's two of them. One of them is common.js, is used for Node and other server technologies. And then the client guys, the server version wasn't fully suitable for the client, mostly because the client is asynchronous. And so they came up with AMD, which is like a superset of that. And there's a snippet of what it looks like here to create these modules. And Verona is using this module system throughout, and it's key to our ability to send down the optimized thing to the client. So you take each module. That mod 1 there is you started off with a define, and you listed its dependencies. In this case, mod 1 is dependent on module 2 and module 3. And then up at the top, in your main line, you require the high-level module, module 1. So I'm going to go show you here. Like here's the grouped bar module, the one that draws bars that go side by side, the render side by side. So it requires down here, this array is the list of modules, and this is a relative path to where the code is. That this thing requires this toClassName module, and it requires D3. And then what happens here is this toClassName, you have to give you give a variable name, which is passed as, and it becomes using a closure. The the reference to the module is available there as a closure, and then you can use it down in the code where I don't remember where that's used. But anyway, so that's the technique that we're using here is we're leveraging the AMD modules and Require.js in particular. So what we're doing in Verona, if you go down to the middle of the slide, is we're building the client code dynamically on demand. So we run the Require.js optimizer on the Verona server, and we build a single file which has all the JavaScript needed by a particular visual. And it's a single minified file. So if I go back here to my, my page here, and I look at network, then this file here is got all the JavaScript that I need to render that one visual in it. And it's not minified because I turned optimize none. If I turn optimize off here and re-render it, and then I go to this guy here, then you see it becomes, this one line here is extremely long. So it's removed all the spaces and everything. So what we've ended up with now is that we're currently at, for a typical chart, around 175K. Now, we're likely could get smaller. We're using Require.js in its fullness, and it's 15K, but there's a version that's 1K called Almond that we'll likely switch to. And then D3, we're not modularizing D3 at all, so we're bringing in the core of D3. And that's an area we'd like to do is to somehow hook up D3 into the dynamic build system. Yes?
So is it going to be basically one compressed JavaScript file per graph?
Yes. Well, I'll get into that in a bit. If you have multiple charts on the same page, then we have a server, a post request that you can give, and it will be one JavaScript, one network request for all the charts on the page. So we run the optimizer against all the JavaScript features that that page needs, not just each chart. We're currently using Require.js optimizer. There's another technology called Zazzle, Z-A-Z-L, that we're looking at. And the reason we're looking at Zazzle is because Require.js doesn't cache on the server the files that it loads. So every time you run the optimizer, it pulls the files again from the server disk. And Zazzle does caching. So we've seen a huge improvement because people use the same server files over and over. So one of the things that we're doing is the thing that I'm showing, that I've been demonstrating so far, is sending down JavaScript, which will then run D3 logic on the client. We've also set everything up so that the server can generate SVG or images. So that can be huge for mobile performance reasons, because instead of running D3 on the mobile client to go build the chart, you run D3 on the server, and then you do an inner HTML over a container div, and you get the SVG stuff, and then you send the SVG to the client. And then similarly, if you don't want to do the SVG route and you just want an image, then you can go run format equals PNG, and we run Phantom.js to go render, which has WebKit inside, or a server version of WebKit. And then we extract the bits and send the PNG to the client. So with the format SVG, we have animations, that if it's CSS animations, those are working. We're looking at to see what kind of interactivity we can support in that. But at the moment, it runs the animations, but it doesn't run the interactivity. The PNG is just a static file right now, although we could use image maps or whatever. Another option that we could add is, format equals canvas, format equals WebGL. but we haven't done that.
John, I have a question. Did you, on mobile, did you see performance, how does it play in terms of performance and formats? Have you already collected data on like sending an SVG versus sending JavaScript or using, I guess PNG would be faster, but I'm sure you have server-side on
So the question for the recording is, have we seen any difference between the performance of the JavaScript versus the SVG? We don't have rigorous tests. We have more anecdotal things that we've noticed. And the SVG seems to be blazingly fast if you don't have any JavaScript. If you just send the markup down, even if there's lots of data points, it seems to parse really fast and render really fast. If you have JavaScript and use D3 and you're having to build everything, that's where the performance issues are.
Okay, I have another question. In terms of declarative animation for SVG, do you use both CSS and smile animation, or is it just CSS?
The question is, are we using Smile or CSS or both? At the moment, we're only using CSS animations in the code. We implemented the Smile stuff at one point, but everything that we're doing right now can be done with CSS. And because Microsoft is refusing to implement Smile, then, for portability reasons, we're just have the one code path right now. Although I don't know about the performance, whether on some devices, that's something we want to investigate, is whether if you use Smile instead of CSS, would performance be better? My guess is, do you know? Does anybody know? Okay, my guess is CSS will be as fast as Smile. So here's one technique that we're using right now on Safari 5 and below for iOS. So the older iPads and iPhones, they did not support CSS animation in conjunction with SVG content. That didn't come till Safari 6. So just for getting an animation to work, we had to find some other way of doing it. And then in terms of the performance of the animation, the smoothness, that there on some devices, CSS with too many data points in SVG, the rendering can be slow because they recompute the SVG in the loop. Even though it's being done in C code, there's still a rendering issue. So we came up with this trick here, and it's a little bit convoluted. It requires the use of 2 canvas tags in conjunction with an SVG. So what we did is we initially render an SVG into a div. Then we will expose that SVG ultimately so that to do event handling, but it's rendered invisibly. Then we render the SVG a second time onto a canvas, and that's for the full SVG. Then we create a second SVG where we do a bitmap copy from the first one to copy the second one, because we want to only animate part of the canvas. So what we do here, if you look in the bottom left there, the whole picture contains the axes, and we only want to animate the plot part. So we take the region there from the canvas and we put it into a second canvas, and then we use CSS to animate that. So I'll show you that here. Oops, that's not what I wanted. Well, I'll just go back here to this guy here. So if you look at this animation here, that you see that it's going from bottom to top. And what that technique is doing is it's animating the part of using canvas to animate the part of the chart that is inside the axis, so the main plot part. So mobile gestures, we're in process with that in terms of implementing mobile gestures. So what we're planning to do for things that have data like line charts and bar charts is to implement a flick operation to move along the timeline, along the x-axis, left and right, a pinch to change the density of the data, and then press and hold on mobile devices to be the equivalent of hover. And one of the things, this is where we're going to want to leverage the client-server technology, so that if you have a big data set, we only want to show a window, and then we'll pull down the data from the server and re-render as necessary. So another part of Verona is that we want to go and make D3 more accessible to mortal programmers. So D3 is a fantastic graphics library. If you go there and you check through there, almost any kind of visualization that people do in the industry, there is a sample for it. It's well matched to big data applications. Its name is Data-Driven Documents. That's what D3 stands for. So it's really well suited for the cloud and streaming applications. And it's pretty tightly implemented. It's got a comprehensive feature set, but it's relatively small. So it's really a great library, and most of the demos that are here at the conference, the graphics demos, are probably using it. But the downside is that it requires major learning curves. You have to understand, be a good JavaScript programmer. You have to understand SVG, which has got its own learning curve. You have to understand how CSS works with SVG. Then D3 has some complicated concepts itself. So what we're trying to do is put a declarative front end on D3 so that lightweight programmers can accomplish a lot of the stuff that D3 can do without having to learn D3. So what we have here, what I have in the left column here is a sample, one of the sample D3 things, and it's 82 lines of source code in order to implement like a line chart or a bar chart. And the things you have to learn there, you have to learn about D3 axes, you have to learn about D3 selections and how it handles colors, etc. There's a big learning curve. So what we've done with Verona is we've got a JSON file that allows you to expose the various features that D3 offers, but to do so by typing in options. And then if I go back to this app, what we've done here with the app is we've created a GUI around those options in the JSON file. So what the thing here is that this is actually driven from that JSON file, and we're using JSON schema for that. So so this is the JSON schema for our JSON format, and that describes what each type of data is. For example, here the layout width is a number. Its minimum value is 0, it's required, etc. And then we use that information to build the user interface here. So anyway, for the chart. So that's the declarative thing that we're trying to do. We're trying to provide a JSON format so developers can actually just modify, build things up, a chart definition by JSON format, and then also make it so that there's a GUI that corresponds to that. So I've shown you the GUI tool, available as a web app, hosted on cloud infrastructure, and we're doing responsive design with it so that it works well on tablets and desktops and phones in the future, where there's still some things on the layout side to make sure it works well on a phone. And the output is an HTML snippet like I showed before. This is what format equals JavaScript. You enter this string here, for copy and paste that into your HTML page. If you choose format equals SVG, then this is actually rendering the snippet right here. This is, you type in an object tag into your page, and then the PNG, similar a snippet here, an image tag. So anyway, so you know, it gives you instant preview of what you're wanting to do. And for example here, one of the things you can do is you can change the animation duration and then change the animation direction from up to the top to left to right. And I don't know if you noticed some funky stuff that happened here, but the visual thing there is when you have a retina display projecting over a screen, somehow or other the Apple doesn't do the graphics quite right. So, but if you don't, if I take off the display, it works fine. Oops. So right now we have some tentative user interface at first. We're going to improve that over time. Some key features that we want to add to this thing here is CSS, things, GUI tools, so you can customize some of the chart with CSS and give you tips about what CSS classes are available. And then have a JavaScript for custom event handlers, like before the chart renders, after the chart renders, and make it so that lightweight developers can do custom effects on things. For example, adding a custom title bar over the chart. So I mentioned that it's built from, that the UI for the GUI designer is built from JSON schema. We're not using, we're trying to go without, as an experiment, we're trying to not use any JavaScript libraries for the GUI app. So we're not using jQuery mobile, we're not using anything like that. Now, we've heard about the new, the library that Adobe has, Topcoat. Well, maybe we'll look at that, but we're not using that either. We're using HTML control styled with CSS. So that seems to be working pretty well. Then in terms of like the user management system for Node programmers, we're using Passport. And for persisting data on the cloud, we're using, right now we're using MySQL plus SQLize, but we're in the process of switching to Mongo and Node RESTful. So like I said at the beginning, this Verona is designed to be extensible. So you can customize the visuals that we have by setting the chart options through the JSON or using the app. You can use CSS and you can add custom JavaScript, which I've talked about. In addition, you can create your own chart types. And the idea is that the Verona source code will be out in the open, and you can go make minor changes by creating a new chart type that just changes one line of an existing chart type, or you can do a whole chart type from scratch. Now, one of the things is that because Verona's got a server component and a client component, from a security perspective, you're allowing users, custom developers, to put server logic on the server. And so the security, thinking that one through, our security thinking is that we'll have to treat these chart types just like they would like a Node module or a Node library, is that they would have to be trusted by the server admin and have to be installed by the server admin. So here's our current status. We've got a lot of stuff working. We've got the Nodes Express server. We've got the JSON format working. We've got JSON schema. There's a validator that we've got hooked in. We're persisting data with MySQL. We're hooked into Phantom.js for the image generation, which actually I have this page here. This is our testing dashboard. We've got the ability, SVG, we can also do SVG, generate SVG plus base 64, which is suitable for the image tag, and the same thing for PNG and PNG base 64. So the base 64 is important if you wanted to do n images at once. So if you have, like in this particular example here, there's 3 charts that are being rendered here, and all 3 of them are being done with PNG. So we give one server request, and the server responds JSON, and inside the JSON is base 64 encoded images. If you choose what we call format equals JavaScript, then you end up with inline SVG. So that's sort of like the default thing is the SVG inline inside of the HTML. You can also, if you use our post request, you can get an SVG stream, and then you can plug that in as inline HTML, or you can't really put it into an object tag because you have to base 64 to put it into an object tag if you're getting it over XML HTTP request. So we've got a fairly complete test suite. We're trying to set this up for open source, so we've got if we do go open source, we'll have a complete test suite that using this files thing, it runs on Node and automatically tests things. And the reason you can do full server-side testing is because D3 runs on the server, require.js runs on the server, so all the key technologies will run there, so you can do server-based testing. We've got our server-side builds working. We can render as all these different formats. We've got our extensibility architecture there. We've got some of the animation techniques working. We've got some things going with mobile gestures, and as I've shown, we've got an early version of GUI tool. So we've got a lot of stuff going. Next step is performance, performance, performance. One of the guys is full-time on trying to ensure that on mobile, that even with large-size data, that we have fast performance. That's in parallel with mobile gestures. We'll try to finish up the work on the GUI tool, add the CSS and the JavaScript, custom JavaScript. Then we're working on data windowing and streaming. We have another project at IBM which is using streaming Twitter data. And so to visualize things there, they're using Verona. So we'll be getting into streaming. And then the features and integration into IBM customer projects. So that's what we're working on the next few months. Then ultimately, like I said, is like I'd like to go open source with this, but I need approval internally. And then productization. One of the things about the cloud is that it actually lends itself to easy productization when you have a web-based tool, because typically, I mean, there's a lot of different chargeback algorithms, but you can set it up so that a user can use your web service and just get charged for network time and resource usage time, and you can put whatever you want in terms of profit margin on that. So that's sort of where the world is headed with cloud-hosted apps. And so with Verona, even if it's sort of a thing off on the side, it could still be a moneymaker just because we could pass charges, resource charges onto the customer. So at this point here, I'm done with my slides. Anybody have questions?
So for example, I have a graph and I want to zoom in. When I'm going to be zooming in, is it going to, for each click, I guess, will it, like initiate a new HTTP connection, go to server, download it, or is it going to be like a WebSocket connection that's actually going to be established?
Well, we haven't implemented that yet, but we were thinking about WebSockets for a persistent connection with the server. If we want to try to minimize the number of times we have to talk to the server and do things locally whenever we can. But when we do need to talk to the server, we were looking at WebSockets. Any other questions? All right. Oh.
I have one. You mentioned earlier in your process that you're doing renderings of SVG to canvas and writing the bit back. How do you work on the security? Is that happening server side or is that happening client side? There's a security issue with canvas rendering SVG, or are you using CanVG, or how do you get work around the security problems in rendering SVG canvas?
Well, what are the browsers preventing you from doing that?
Like if you're trying to grab the pixels from canvas after basically the canvas is painted after rendering SVG into it. So if you're trying to grab these bits, then you need a security exception.
Yeah, well, I haven't seen that. Maybe the security features are implemented in more modern browsers, and we just haven't run into that. Yeah, so I was able to take the bits from one canvas and make an image that used those bits, and then take the bits from the image and put them into another canvas. All right, well, thank you, everybody. Thanks for coming.